What if an entire planet could disappear, not behind clouds, but behind dust? Why does this barren world unleash storms so powerful they swallow the entire planet? On Earth, storms come and go, but on Mars, they can take over everything.
This is Mars, a cold, dry world where dust rules the atmosphere.
Martian dust storms begin as tiny disturbances, but quickly grow into massive systems. These storms can start anywhere from deep valleys to vast open plains. It all begins with heat. Uneven sunlight warms the surface, creating rising air currents. As winds strengthen, dust particles lift and collide, feeding the storm.
Small storms combine, forming something far more powerful. Soon, entire regions vanish beneath a moving wall of dust.
And sometimes the storm doesn't stop.
Some storms grow so large they cover the entire planet. The sun itself becomes weak, struggling to shine through the dust.
Mars has a thin atmosphere, yet it allows dust to stay suspended for long periods. Unlike Earth, Mars cannot quickly pull dust back down. Its dust is incredibly fine, almost like smoke.
Trapped heat fuels the storm, making it even stronger.
It becomes a self-sustaining system, circling the entire planet. On Earth, storms are powerful, but on Mars, they are unstoppable.
And yet, after weeks or months, the storm finally fades.
Some Martian storms grow so large they can be seen from millions of kilometers away. These storms don't just appear, and they evolve over days, sometimes weeks.
Even the tallest volcano in the solar system disappears beneath the dust. Entire canyons become channels, guiding rivers of dust across the planet. On Mars, dust never truly settles, and it waits to rise again.
A desert storm on Earth may cover a city, but on Mars, it can cover the world. Earth's dense air limits storms, and Mars's thin air lets them grow uncontrollably. Lower gravity means dust falls slower, giving storms more time to expand.
And once the dust rises, it traps heat, feeding the storm from within. This creates a powerful feedback loop, making the storm stronger and stronger. What if you were standing on Mars as one of these storms began?
You wouldn't see the sun, only a dim orange glow.
The storm wouldn't roar like Earth, but it would surround you completely.
It could block sunlight for weeks, shutting down solar-powered machines.
This is exactly what happened to past Mars missions.
The Opportunity rover lost forever in a global dust storm.
Eventually, the storm loses energy and begins to fade. The planet slowly reveals itself again, as if nothing happened. But each storm changes Mars, reshaping its surface over time.
And even in calm moments, the dust never truly disappears. Mars's atmosphere is thin, but it allows dust to rise higher than you might expect.
Sunlight heats these particles, turning the entire atmosphere into a heat engine.
This uneven heating creates powerful winds, driving the storms across the planet. Eventually, the storm becomes part of a global circulation system.
But could humans survive on a planet where storms never truly end?
Future colonies would need to withstand weeks, even months of darkness. Solar energy would become unreliable, forcing humans to find new power sources. Even constant cleaning might not be enough, as dust returns again and again.
The storms may not destroy structures, but they test survival in every way.
Navigation, communication, and visibility all become major challenges. Mars is a world of extremes, silent, yet violently active.
Its storms are not rare events. They are part of its identity.
Over time, these storms reshape the entire planet.
And when the storm ends, the dust simply waits. Two planets shaped by the same sun, yet completely different in behavior. On Mars, even calm is an illusion, and the dust is always moving.
A planet where storms can swallow the world, and silence hides constant motion. Mars reminds us how fragile balance truly is. A world where even the smallest particles can control an entire planet.
And in the end, Mars teaches us that even dust can become unstoppable.